Hi guys, greetings. Welcome to this presentation of look-through objects. So this is a step-by-step demonstration of how to use my commercial grade assets that allows you to fade the objects that occludes the player while going around a level on a top-down or a third-person game. So this setup you see here on my screen is a standard setup that has been built using the standard assets prototyping package. Okay, well, I created some more colored material using the same assets. We have a camera that has the look at target script on it, pointing obviously to Ethan neck. So it keeps our friend Ethan here always pointed. So it keeps looking at Ethan. So if I run this scene, obviously what I get Ethan disappearing behind objects. So it's pretty much unusable, right? And this is something that even if brought to an extreme, it's what happens regularly without a tool like this when you create a level that has some objects like this, some complex scenario. So just to clarify here, I've prepared already the scene having the yellow pillars belonging to a layer that is called yellow, and the gray ones a layer that it's called grays. The orange one belongs to a layer called oranges. So just to be, ahead of time. So I also already imported the the asset. As you can see, I have the folder DFT aims, and we have fade occluders folder in it. Okay, so this contains the scripts. Now, the scripts go on the camera. So how do I implement this? Let's start with a standard simple implementation. So I go on the camera, add component, I have here camera, and I have two different scripts, fade obstructors by raycast or fade obstructors by volume. Now, what's the difference? We'll see this in a moment, but anyway, this is raycasting. This one uses a trigger. Okay, so obviously the one with the trigger costs less if you don't have a too busy scene. If your scene is too busy, then we end up with the second one, the volume one, costing more. So you have to check the performances, have a look at the stats, and decide if we prefer to use the raycasting, sphere casting, or the volume. Why I say raycasting and sphere casting? Because the raycast can be modified to get a sphere casting. Now, I start adding just one. As you can see, it already presents a transparent material. Let's have a look at this. It comes with a package. Sometimes when you import into Unity, you don't get layers. This one, instead of being on fade, is on opaque. So I don't know. When you import this, just make sure that you have this material properly set. It doesn't really matter the color or if you have a texture or not, to some extent. Now we'll see what I mean here. Anyway, you need to assign a material, so the material that you want to use. And this allows you to, for instance, have some smoothness, to add some emission. So you can basically customize the material as long as it's a fade rendering mode material, because otherwise it won't work correctly. Now, obviously, this is Unity 5. I dropped the Unity 4 support, which means that we can use the standard shader. So we have the shadows kept, even if we are transparent, which is nice, right? Okay, so let's go back to our camera. Here we go. So first off, after the material, we have replicate texture. What is replicate texture? Basically, I can choose to have the transparent material used as it is, or I can tell the component to use the same texture that is applied on the object. Okay, so at the moment I leave it as it is, also because there are no texture here on those pillars, so it makes no sense to have that. So fading out time. Now, obviously, this is, well, I should change this. It's not just fading out. The same goes for fading in. So how much time it will take to have the fade in, fade out effect. The default is 0.3, is 300 milliseconds, which is acceptable. The fading amount, so how much this has to be transparent. So the standard is 30%. So I see only 30% of the object. I can just zero these out, right? Anyway, let's hit Ctrl Z. Let's go back. Then, do I ignore triggers? So the default is yes, I do ignore triggers, because otherwise you're going to get a very odd effect. If you don't want to ignore triggers, you better think very well how you organize your scene, because otherwise you're going to get undesirable effects. Then we have use sphere cast. What's use sphere cast? This is something that is pretty much what it seems to be. So I can, instead of casting a ray, I can decide to cast a sphere. Now the sphere default value is 0.5, which is not great. Let's go 0.25. Okay, 25 centimeters radius, which gives me a sphere with a diameter of half a meter, which is pretty much correct for Eaton here. So let's use the sphere cast. Now the fade color. At the moment I don't want, so I just want to keep it white for this first test. And the layers to fade, for now, let's fade everything with this component, okay? Now, player transform, I can just bring the player transform in, or leave it as it is, and that will just look for the player, okay? Now, one thing needs to be said. It's always better to not leave this automatic, okay? So basically, what I mean by this, usually the transform, you see, this is Eaton, this is the transform. Obviously, the transform in Eaton, just like most of characters, is set at Eaton's foot, okay, to his feet. That means that when we sphere cast, but even ray casting, we are going to get, for instance, the floor, or maybe we are going to get, if our player is jumping around and hits a table, he stays on a table, and the sphere casting hits that table, it's going to fade the object that is under the player's feet. So we don't really want that, right? That's why it's better to tell the component to actually do something like the same the look at target does. So eaten neck is pretty much okay. So let's spherecast to eaten neck, which is good. Is a good target. Okay. The offset of the raycast is basically a little bit of distance that we want to put between the end of the raycasting and Ethan's neck. So do we want to get down to Ethan's neck with the center of our sphere? Not really. If our sphere has a radius of 0.25, we stay away from Ethan by half a meter. So that means that we are the surface of the sphere that we are casting stops at 25 centimeters before the actual neck of Ethan. This gives us a little bit of space, which is good to avoid fading something that we don't really want to. Okay. And this, everything that I said until now is basically valid also for the other component, which instead of ray casting or sphere casting uses triggers. So what I said until now is exactly valid also for the other component. Okay. Now we have this, and it's fading everything. So let's run the scene and see how that works. Okay, so let's have a little more space here in the scene view. Here we go. As you can see, there is a ray casted between the camera and Ethan. This gives you also the distance. You see that half a meter before Ethan's neck. Okay, so you can see you have a visual feedback, right, from the component. But let's play now Ethan. So the camera is not gonna move, only is only gonna look at Ethan. And here we go. As you can see, we have a fading in, fading out. And this is pretty much all it does. Now, obviously, this is the basic thing. We are just fading using a standard shader with nothing in it, and we are not replicating texture. And we are fading the same way everything. Okay, but usually this is not really what you want to do in a game, right? What you want to do in a game maybe is to, for instance, if you think of Diablo, right? Everything fades out a little bit, everything becomes a little bit transparent, with one exception, the roofs. Okay, for instance, the roofs, they just disappear. They don't just fade out and stays almost visible. They just disappear, right? So let's make this a little bit more interesting. Now I want to keep all these parameters for. So what I'm gonna do? First off, I put the layers to fade to nothing, and then I copy this component, okay? Because I'm lazy. So then I go here, transform, paste component as new. Okay, now we have two, they have the very same setup. And because I have three different layers, I want to just add a new component again. So now I have three of these. As I said, here I have the orange, the grays, and the yellows layers. So let's say that this one is going to go for the grays. And I want the grays to fade using a red color. Then I want the yellows. I want the yellows fade and use green, bright green color. And then the grays, the yellows, the oranges. Now the oranges, let's simulate that these oranges are not really pillars, so they are the roofs. So on this one, I actually want to have this going away completely. So I want to go and zero out the fading amount. Okay? So 0, transparent, 100%, they will just disappear. Let's see how this works. Yeah. So we have eaten the grays, that becomes reddish, yellow, greenish, and we have the orange that just disappear. Now, you can see that they do disappear, but there is still the shadow that is there, right? Now, to avoid that, we can tell the system to, instead of going completely 0, if we don't want to keep the shadow, we go like 0.09, something like that. Let's see. Here you go. 0.9. There is still a hint. Let's try 0.7. It's very sensitive, and here we go. I think it's pretty much okay. Let's try 0.5. Even better, I guess. No, 0.5 is too much. Okay, 0.6. Sorry for that, guys. I don't really use roofs completely invisible. That's my choice. I was just thinking, here we go, 0.06. So I just wanted to give you the correct value right away. And here we go. Now, I use a pretty much steady UV, so here with this setup, I think it's going to be difficult to demonstrate the replicated texture, now that I think about this, because these things have a horrible UV map. So I think that I'm gonna do this in a different video to demonstrate it. There is a tiling thing. When the UV is not okay, we might have issue with the tiling. Next update, I will just expose the tiling in the options here on replicate texture, so that it will be possible to adjust that on materials that have an uneven UV. Okay. At the moment, if I invite you to give it a try, you'll see that replicating texture might give some odd result. I can show you that here, but it's not really great. Also because I don't really have many texture here. I guess this one is the one that better will help demonstrate this. Okay. So for some reason, when we go, let's see. This is as a 4x4 tiling. Oh, maybe that we can manage 4x4. Let's put it 1x1. Yeah, this is setting this straight. No, it's all right. It's okay. I guess we are lucky. Okay, let's give it a try. And that was the yellow, so it's this one, right? Replicate texture, and let's go. Here we go. So that's the orange that disappears, that's the yellow, and as you can see, yeah, it's okay. It's okay. It's not that messed up, actually, the original one, right? Let's make it white, so that it keeps the actual color of the texture. Let's go here, it's more visible. Here we go. And we have a proper, yeah, it's not that messed up, to be honest. I thought that it was worse, but it's not. So it's okay. And we have been able to demonstrate also the texture replication. What else do you want, guys? I guess that it's great. So obviously you can play with the sphere cast radius. As you can see, here I'm playing with the radius, so we have a huge sphere now here. It is, see. So this will allow you to do a lot of nice things. You have to, properly compute by hand, literally, by trial and error, which is the best way to go. Okay, because there is no one silver bullet. Maybe you need to have multiple of these, just like on this camera, and maybe you do need to have different sizes as well, or maybe you just want to use the standard raycast with just one tiny ray. That's depending on your environment, depending on how you go about setting it up and how the player moves around. Now, let's have a look very quickly to the other component at this point. Okay, so let's remove this ones. And let's quickly have a look to the other one, which is the one by volume. Now let's add 3 of these, just like, well, wait a second, I will make copies because I'm lazy. So let's do this. Known, the player transform. Let's get to the neck again. Here we go. And now we can copy this and we can paste as new and paste as new, and we have this and the grays and the yellows and the oranges. Here we go. Now the yellows, we say that we have a texture replication, right? What was that? Let's well, let's put the grays in bluish, like that, and the orange, yellow. Here you go. Here we go. Now, as you can see here, there is another parameter, common volume, or with a common radius. So this is the radius of the let's look at it in real time. You see, we here project a capsule toward the player. This is a trigger. Now, we can have a common value, a common volume, or if I uncheck this, I actually have an independent radius. So I can have this one is not working, cannot be changed while it's running. So let's say that I want to have this one that is 0.25, this one that is 0.3, for instance. When I run it, you see I have now multiple capsules with multiple diameters. Okay, so this is completely up to you. This gives you a lot of flexibility, but if you go for common volume, you get one that goes for everything. Okay, So then if I run this, this now has the very same diameter of the sphere that we were casting before. The difference is that now this is based on triggers. Okay, so as you can see, I cast that trigger is a capsule, and the result doesn't change. It's exactly the same result. Obviously, this is a little bit less heavy compared to sphere casting, depending on the environment, depending on the amount of colliders. You have to give it a try and see which one of these components performs better on your scene. Okay. You can see here the stats. I have 96, 100 now FPS. Let's disable this now so that I can give you. So this is it. Now I disable completely these three. Okay, so now we don't have this working. You can see the frame rate. It's 93, 98, 90, 100. Well, it's between 95, 94, 100, 100 something. If I enable this, 1, 2, 3, as you can see, it's not really gonna change a thing. Okay. Not, I need no hits at all on performances. Everything works just as fine as it was working before. It's fast. Obviously, if the scene is seriously busy, you might see a difference between the two components. Now, on a scene like this one, they perform the same. So you really need to see what you prefer. Do you prefer ray casting, sphere casting, or triggering? Sometimes you might also have difficulties with using triggers because maybe you don't want to have triggers colliding or stuff like that, depending on the setup in your scene. So that's why we have two components, and they have different behaviors, and so that you can have a full flexibility and you can choose which way you want to organize this. The only thing is we want to have a proper result. And I'm pretty sure that this component would give you exactly that result that you are looking for. Okay, how? Raycasting, triggering by volume, that's completely up to you. You can choose. So I hope that this sums it up pretty well. I hope that everything's clear. In case something is not clear, there is the wiki. You can ping me, you can send an email, you can open a ticket. Anyway, enjoy, and thank you for watching.